6 is titled Special Right Triangles. So by the end of this lesson, you'll be able to find the missing side lengths in a 45, 45, 90 right triangle and in a 30, 60, 90 right triangle. So first I want to just talk for a moment about what those terms mean. If we have a 45, 45, 90 right triangle, that means it's a right triangle because of the 90 degrees, but that the other two angle measures are both 45. Similarly, in a 30, 60, 90 right triangle, it's a right triangle because of the 90 degree angle, and the other two angles will measure 30 and 60. So first let's talk about the 45, 45, 90 right triangle. In this triangle, there are two things that you need to understand. And this is going to help us not have to use the Pythagorean theorem, because in all 45, 45, 90 right triangles, the following are true. First, the legs are the same length. And remember that the legs in a right triangle are the two legs that make up the right angle. So this is our leg, and this is the other leg. So those two legs will be the same length, and you can see in this picture that they're each a foot long. Also, the length of the hypotenuse is the square root of 2 times longer than the legs. And so it's important to understand here what that means. It means you take the length of the leg and you multiply it by the square root of 2, then you'll get the hypotenuse. So in this case, the hypotenuse is unknown, and the leg is 1 foot. So the length of the hypotenuse would be 1 times the square root of 2. Well, that's the same thing as just saying the square root of 2. And we're not going to worry yet about what that is in a decimal. So the length of the hypotenuse here is the square root of 2. So let's look at another example. Please make sure you're drawing these triangles in your notes. So here we want to find the length of the hypotenuse. It is a 45, 45, 90 right triangle. We know that the two legs are the same length. They are both 8 inches. And those red dashes indicate that those side lengths are the same, or congruent. So I want you to find the hypotenuse. Well, we just learned that the hypotenuse is the leg times the square root of 2. 8 times the square root of 2. And that's the same as just saying 8 square root 2. And we aren't really concerned yet about what that is in a decimal. Make sure we have our unit here of inches. We aren't concerned yet what that is in a decimal. Your answer can be the 8 square root of 2. And I think I need to go back. I didn't put feet on this example. Here we have another example. Now the legs are both 3 centimeters in length, and I want you to find the length of the hypotenuse. Well, again, remember that the hypotenuse is the square root of 2 times longer than the legs. So if the legs are 3, then the hypotenuse is 3 times the square root of 2, or just 3 square root 2. And again, we need units, centimeters. So you're basically just taking whatever the length of the leg is, and you're multiplying it by the square root of 2. This example 3 is a little bit different, because here we are given the hypotenuse. Remember, the hypotenuse is the side opposite the right angle. So this is your hypotenuse now. And we're given one of the legs. The one here at the bottom, we're told that it's 9 meters. But remember that the legs in a 45, 45, 90 right triangle are congruent, or are the same length. So if it's 9 meters down here, then this is also 9 meters. Now let's talk about a 30, 60, 90 right triangle. This again is a right triangle because of the 90 degree angle. And the two other angles measure 30 degrees and 60 degrees. So first, the hypotenuse is twice as long as the shorter leg. And it'll be evident in the picture which one is the shorter leg. Also, in a 30, 60, 90 right triangle, the length of the longer leg is the square root of 3 times longer than the shorter leg. And I want you to find the lengths of the missing sides. So here in this picture you can see we have the longer leg, or the shorter leg, a foot. So the first bullet said that the hypotenuse is twice as long. So you find the hypotenuse, x, by taking 2 times 1. That's when something is twice as long, it's the same as multiplying it by 2. So here we get 2 feet for the hypotenuse. That's twice as long as the short side. Then the other leg, the longer leg, which here is labeled y, is the square root of 3 times the shorter leg. So again, to get this, you take the shorter leg and you multiply by the square root of 3, or you just get the square root of 3 feet. And again, we're not as concerned what that is in a decimal just yet. So you're just multiplying 1 times the square root of 3. So let's look at some examples. I want you to find the lengths of the 2 missing sides. Here we're given the short leg. We're trying to find the hypotenuse and the long leg. And we can do this without using the Pythagorean theorem. That's what's so special about these 2 right triangles, is that you can find the side lengths without using the Pythagorean theorem. So the hypotenuse is twice as long as the short leg. So if the short leg is 4, then we multiply 4 times 2, and we get 8 centimeters. The longer leg is the square root of 3 times the shorter leg. So we take the short leg times the square root of 3, and we get 4 square root 3, and that's centimeters. And we'll talk in a moment about what that number actually is in the calculator. Again, please make sure that you're drawing the triangles in your notes. Example 5, still a 30, 60, 90 right triangle, but this time we're given the length of the hypotenuse. This is the hypotenuse. We're not given the shorter leg. But if we know that the hypotenuse is twice as long as the short leg, then we can just take the hypotenuse and divide it by 2 to get the length of the short side, 3 inches. 6 divided by 2. It's half of the hypotenuse. Then we need to take that 3 inches to help us find the longer side, because we multiply it by the square root of 3, and that gives us 3 square root 3 inches. So we can find the length of the missing sides given the short side. We can also find the length of the missing sides given the long side, the hypotenuse. Now we have more of a real-world example. And here we have a 10-foot ramp. Notice that the ramp is labeled 10 feet long, for loading an ATV onto a truck, and it makes a 30-degree angle with the ground. So you can see here's the ramp and the 30-degree angle with the ground. We are asked to find y, which is the distance from the truck to the bottom of the ramp. So we have a truck here that's going to load up, give it really big tires because that's a pretty tall ramp. We have a truck here, and we're going to load the ATV onto the truck. We'll call it ATV Moving Company. And we want to know how far from the ground the truck and the ATV are. We know the angle measures 30, 60, 90, and we know the hypotenuse. We want to find y, and what's important here is to understand that y is the longest side, or the longest leg of that right triangle. So I'm going to draw the triangle over here again. This is 10, and we don't know y. We also don't know x. We don't know how tall the bottom of the truck is. So first we want to find the x. Remember that x is half the hypotenuse. So that's going to be 5 feet. So now in order to find y, we just take that 5 feet, that short leg, and we multiply it times the square root of 3. Now notice here it does say to round to the nearest tenth, which means we are going to put this in the calculator. If you're using a calculator from my classroom, you need to do the square root of 3 first, and then multiply it by 5. So in the calculator, you'll do 3 and take the square root of it. You get 1.732050808. Multiply that by 5, and we're rounding to the nearest tenth. So here you get 8.660254, and it goes on. We want to round to the nearest tenth, so that's going to be 8.7 feet. So the ATV and the truck are roughly 8.7 feet apart from one another on the ground. That's the distance on the ground there, that Y that we were trying to find. So we talked about two types of examples of special right triangles, a 45-45-90 right triangle and a 30-60-90 right triangle. What's important to remember here is that you can find these side lengths without using the Pythagorean theorem. You can remember what you multiply by. And we'll practice that on our worksheet. That'll be 10-6.